Hello, this is Dr. Liu. This video, I will use it to Hello, this is Dr. Liu. In this video, I will explain how to do vector decomposition. And actually, you can also do composition, which means you combine different vectors, or in this case, components of vectors into the vectors themselves. So these are the equations I discussed in the previous video of vector basics. So this A is the magnitude of a vector A, and the theta is the angle of A with the x-axis. So we have something like this. So here's a vector A. The length is A without the harpoon hat, right? And this angle is called theta. So that's the definition of this A vector. And these two equations give us means of getting the components of the A. So this vector that I drew approximately was 3 blocks wide, right? So here 1, 2, and 3 blocks wide, right? And also approximately 2 blocks tall. So this will be the AX, 3 blocks. This is AY, 2 blocks in the orthogonal direction. So that's what these two will produce, equivalent to what you can see on the diagram, right? So that is how many blocks horizontal, how many blocks vertical. All right, so let's do some examples. We have first one example with A equals 10 and the angle is 30 degrees. So AX, according to this equation, is A cosine 30 degrees, so 10 cosine 30 degrees. So that's 10 times cosine 30 degrees is 0.866. Okay, so we can check that. So cosine 30 degrees. Okay, 0.866. I typically just memorize the first 3 digits after decimal, so I don't have to keep using my calculator. Alright, so that is the length. If you multiply this by 10, you shift the decimal place. It's 8.66. I'm keeping 3 digits. So 8.66 long if you are 10 units along a 30-degree angle. And AY is equal to 10 sine 30 degrees. So that's 10 times 0.500. That's sine 30 degrees. So let's check that. Sine 30 degrees. So that is effectively 0.500. I usually use this sine 30 degrees to check whether my calculator is in a degree mode or reading mode. If I can't really tell what mode it's in, if I do sine 30, if it gives me 0.5, I know it is in degree mode. If it doesn't give me 0.5, it's probably not in degree mode. Okay, so that is 5. So this is how you decompose a vector 10 units long along the 30-degree angle into 2 separate component vectors in the x direction or horizontal and in the y direction vertical. So let's do some more examples just to show what vector decomposition is like. So the next one is A equals 5 and the angle is 60 degrees. Okay, so you have a larger angle. That means you probably are a bit over the 45-degree diagonal, so you'll have a shorter x component, a longer y component. This 30 degrees, you're below the 45-degree diagonal, so you have a longer x and a shorter y. See that? Slightly longer in x than it is in y. Now we have a sharper angle, then we should have the opposite. The x component is shorter, y component is longer. So 5 times cosine 60 degrees. And cosine 60 happens to be the same as sine 30. So this is 5 times 0.5. 2.5. And then a by 5 times sine 60 degrees. And sine 60 degrees happens to be the same as cosine 30 degrees. So 5 times 0.866. Okay, I don't know what that is, so I'll just use my calculator. So 5 times 0.866, 4.33. 4.33. So since we're above the 45 degree diagonal, the x component is a little shorter, the y component is a little longer. Okay, just to show the point of the decomposition, I have this vector simulator. So let me just drag something over here. Okay, I have the sum enabled. Okay, so 45 degree angle is okay. Let's maintain a 45 degree angle. Okay, here's 45 degree angle. So you have equal lengths in x and y. So if you're a little above 45, then your x is shorter, your y is longer. If you're a little below 45, then your x is longer than your y. Right. So that was the point I was showing in these two examples. So let's go through another example. And in this example, a is equal to 8. So a is equal to 8 long, and the angle is equal to minus 25 degrees. So what exactly is our negative angle? What does that mean? Okay, so negative angle is when you have, for example, like this, the fourth quadrant. You're, instead of above the x-axis, from x-axis and above, you're below the x-axis, so that angle is counted as a negative angle. I don't know if you can create, oh, I created 25 degrees exact, okay. Alright, so I have 25 degrees and I don't really have an 8 because this thing runs on a grid. The grid doesn't have a diagonal of 8 necessarily, so I can try and make it close enough to 8. Yeah, that doesn't work. I don't really know if I can do that. Anyway, so the negative angles are below the x-axis. You can go up to negative 90 and negative 180. Alright, so that's what the negative angle means. So you should anticipate a negative y component and a positive x component. And you don't really have to put any negative signs, attach any negative signs. Your positive and negatives are actually, they are handled by the sine and cosine functions themselves. So let's see how that comes out. So ax is the magnitude a times cosine minus 25 degrees. So this is 8 times, let's do cosine minus 25 degrees. So cosine minus 25 degrees. Okay, well, let's also, for comparison, do cosine plus 25 degrees. Wow, those are the same. Well, actually, cosine is a function, we call it an even function. So the positive and the negative, they generate the same exact cosine function value. So cosine anything negative is the same as cosine anything positive. So let's just take this value of 906. 0.906. So now we can multiply these together. So the previous answer times 8. So I have in 3 decimal places 7.25. 7.25. And then AY, this is the one I anticipate to be negative because this negative angle puts my vector in the fourth quadrant. It should have a down pointing y component. So let's see how the trig functions are generating negatives. Okay, this is 8 magnitude times sine negative 25 degrees. So that's 8 times, so sine negative 25 degrees Okay, so that itself is a negative quantity. So now I know where that negative came from. It came from sine of a negative angle. What about sine of that same angle but positive? Well, that's interesting. That's the same exact magnitude, except it doesn't have the negative. So that is because sine function is an odd function, which means sine of the negative quantity is the same as the sine of the positive quantity with a negative attached to it. So I'll write these down after the 4 examples. So there's one more example I should finish. So let's copy this down. 0.423. So 0.423, and we use that answer times 8. So 3.38. 3.38. Okay. Sorry. I think I forgot the important and negative. Okay. Move that back a little. Ooh, left a dot. Okay, so it's negative 3.38 is negative because we anticipate this angle below the x-axis to produce a negative y component. Okay, so one more. This is the last one. The magnitude A has a magnitude of 12, and the angle is 120 degrees. So this puts us in the second quadrant. Right? 90 degrees is the first quadrant to the second quadrant. So this is over 90 degrees. So let's do this. AX is 12 cosine 120 degrees. Okay, so let's do that. Cosine 120 degrees. Since this is the second quadrant, right? You go over the 90 degrees, the second quadrant. This we should expect a negative x component. Okay, minus 0.5. All right. That is going to give you an x that is negative, right? So 12 times minus 0.5. So this is minus 6. Okay, so let's take a look at this vector simulator here for the second quadrant vectors. So let me move this over to the second quadrant. As we can see, the angle starts to exceed 90 degrees as we go through the second quadrant, right? The second quadrant has a negative x component pointing to the left, but still a positive y component pointing upward. So that makes sense that we actually ended up getting a negative x because it's in the second quadrant. Okay, so back here, a y is 12 sine 120 degrees, and this is 12 times, so sine 120 degrees, 0.866. All right, that seems familiar, right? 0.866. So multiply the two values together. Previous answer times 12. That gets us 10.4, 10.39, right? 10.4. So 10.4. Okay, so the 4 examples are quite typical. The first 2 are in the first quadrant. I compared the relative magnitude with an angle lower than 45 degrees. The x is longer than the y. With an angle greater than 45 degrees, the x is shorter than the y. And then the third example has a negative angle. That is the fourth quadrant, or below the x-axis. And then we expect a negative y. And it turns out the negative y was generated by this part, the sine of minus 25 degrees. So you absolutely shouldn't put any negative signs where you didn't have them. This negative came from the result of sine function. And then with this angle that is in the second quadrant, we anticipate a negative x component, and that was obtained by just doing the cosine 120 that has a negative sign, right? The negative sign came out of the cosine, and then you have a negative x component to represent a vector in the second quadrant. All right. So we also observed something that's interesting. It was cosine of a negative angle the same as cosine of the positive angle. So cosine minus or plus 25 degrees are the same, 0.906. On the other hand, sine minus 25 degrees was actually the negative of sine plus 25 degrees. Sine plus 25 degrees was the 0.423, and sine minus 25 degrees was minus 0.423. So we have this thing that I want to remind the audience. Sine minus x is the same as the minus of sine x, and the cosine minus x, on the other hand, is the same, exact same as cosine of x. So this function we call it odd function because of this relationship with the negative. This function we call an even function because of this relationship. Having a negative in the parentheses, it is irrelevant. So you can pretty much just ignore that negative if you want. Okay, so now we have explored enough of the decomposition. We should also explore the composition, trying to construct the vectors with these components. So I also have 4 examples. So let's go through them. The first one is we have, let's see, ax is 4. Okay, ax equals 4, and ay equals 3. So we're trying to find a. So a would be ax squared plus ay squared square root. So a is equal to 4 squared plus 3 squared, then square root. Oh, I probably should have used a ruler. Oh. Okay, yep. So what's this value? Okay, if you're familiar with this, it's a 3, 4, 5 right angle triangle. So 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. Okay, so square root 25. Let's write it down. And that is a 5. So we got the magnitude from the components. And the angle, okay, so the angle is arctangent or inverse tangent of ay over ax. Ay is 3, ax is 4. Well, we can't really tell this value unless we use the arctangent function. Let's move the calculator to this side. So arctangent, okay, ay over ax, 3 over 4. And this is in degrees indeed. So 36.9 after rounding, 36.9 degrees. Let's banish that. So it's 36.9 degrees. Okay. And there's also this adding 180 in case ax is negative, but my ax is positive, so I'm not adding 180. Alright, so let's move on to the second one. Our second example has, let's see, ax is negative 4. So this is ax is negative 4. Ay is still 3. Okay, so a is equal to, of course I can put negative 4 in the square root and then square the negative 4. I really don't want to square negative 4 just in case if I punch into the calculator with the wrong sequence and negative somehow didn't get squared, then I would get a wrong answer. But since negative 4 squared is the same as 4 squared, I don't really do the negative. I will, however, do it a few times just to remind the audience what I am actually doing is to square the negative 4, but that's the same as squaring the positive 4. Square. Okay, so that is again 16 plus 9. So this seems like the length is the same, and the square root of 25. I'll probably skip some of these steps next time. Is a 5, and the angle tangent minus 1. Ay is a 3. Ax is minus 4. Okay, so let's see what our calculator tells us. So A10, oops. So arctangent 3 over, remember and parentheses -4. Okay, so that is minus 36.9. Okay, I see. Minus 36.9 degrees. But wait a second. Am I supposed to have negative angles at all? Are they actually valid? The answer is negative angles are valid, but this is not the right answer because here we have very clearly at 180 degrees if the AX is negative. And is our AX negative? Yes, it is negative. It's -4. So this is why we're adding a 180 degrees because AX is negative. Right? So this gives us previous answer plus 180. So 143 degrees, rounding to 3 decimal places, 3 digits, 143 degrees. And this makes sense. We have a negative x, so that puts us in the second quadrant with a positive y, right? Second quadrant. And in the second quadrant we have over 90 degrees, but below 180 degrees. So that makes sense. So this example is telling you when to add 180 degrees. It is when you have a negative AX. Okay, so let's move on to example 3, where we have AX equals 9 and AY equals -5. So a positive x and negative y puts us in the fourth quadrant, that is below the x-axis on the right side. So let's get A. A should be 9 squared plus 5 squared. See, I'm no longer squaring the negative. It's pointless to do that. And 9 squared is 81. 5 squared 25. So that's 106. Okay, so let's square root 106. Or we can just do this, 81 plus 25 raised to the power of 0.5. So it's 10.3, rounding to 3 digits, 3 sig figs, 10.3. 10.3 long. And the angle, tangent -1, or arctangent or A-tangent, AY is -5, AX is +9. So -5 over 9. Okay. That gives us a negative angle. Okay. So a negative angle is -25.0. Or if I round to even, If I don't round to even, I get -25.1. So let's do round to even, -25.0. So -25.0 degrees. Am I supposed to add 180? Of course, because it's negative. No, wait a second. Is it negative? Angle that requires adding 180 degrees. I thought so. No, actually it's not. It is this, right? X component is negative. And this one apparently has a positive X component. So when you see a negative angle coming out, don't try to rush into adding 180, right? That is not the condition. To have a negative angle requires 180 to be added. The necessary condition is to have a negative X component. We have a negative Y component, it's not a negative X, right? So let's make sure we mark this mistake. This is a very typical mistake. We're not adding it. This is because AX is not less than 0. AX is 9. So we have a -25.0 degrees. Let's also say this is rounded to even. Otherwise, we would have gotten -25.1 degrees. So this is just playing with the new rules. So a negative angle, it makes sense. Negative angle is below the x-axis. So as you may see here, if I move the vector below the x-axis, we start getting negative angles. I wish this number can be a little bigger. Okay, so we get negative angles, and negative angles do exist. Okay, so one last example. I know this is a long video. This is the last one. So we have -5 and -1 as components. So ax is -5, ay is -1. Okay, so just off the bat, this is a negative number. Warning, right? We need to add 180 degrees to the arctangent. Okay. So not squaring any negatives. Oops. That should be 1 squared. So 25 squared and 1 squared, that's 26. Not 25 squared. 25 plus 1 square root. So this is 26. And that should be pretty close to a 5 if you square root it. So let's do that. Let's see where that is. Okay, here. Move it aside, clear that way. So 26 raised to the power of 1/2. That's taking a square root. So that's 5.09. If you round it to 3 sig figs, 5.10. 5.10. Okay, angle. So angle here, theta is tangent -1, -1 over -5. So this gives us tangent -1 of 1 over 5. So this is a perfect example to show you why you have to add 180 degrees. See, the -1, -5 sits in the third quadrant. Both components are being negative, right? You point to the left and then you go downward. So that ends up in the third quadrant. But the fraction between these components looks like they're in the first quadrant of a positive x and a positive y and positive x. So that is in to the right and up. That's in the first quadrant. So this is why we have to add 180 degrees in case we have a negative x, because that kind of just wraps us back from the third quadrant back to the first quadrant by wrapping 180 degrees back. So we're going to have to add it back in. So this is going to be adding a 180 degrees. So let's do tangent -1, arctangent 1 over 5. Okay, so that's a positive angle, but it still is not a valid result because it wraps a third quadrant angle into a first quadrant angle. So let's add that by 180 degrees. So we'll have 191 degrees with 3 sig figs. So this is 191 degrees. This is because AX is less than 0. So how about, just for complete correctness, I'll move this back a little. I'll just say add 180 degrees. Then we're exactly equal, right? Because before I only had the arctangent. Now I have the arctangent plus 180 degrees. The reason being negative x components. Thank you.